I think the biggest achievement that we could strive for as a society is steady state. A point where we're not taking out more than we're putting in.
Ask yourself, not what would be better, but ask yourself, what would be ideal?
Yeah, the US EPA, here in the States, did a survey of landfills back in 2003. And what they found is that 20% of landfills by volume are expanded foams. Now that's huge. Normally you don't hear about that because everything's measured by mass. These materials don't weigh anything. They're mostly just fossil fuels and air, right? But then you think about it, for every single cubic foot of styrofoam, it's about 1.5 liters of petroleum. And that's energy that's well suited to heat our homes or fuel our cars, not for throwing it right in a landfill.
The scenario we want to avoid is runaway, right? Suddenly you have hit a tipping point and things get really bad really fast and it's too late. And for us, we don't want to make this technology adopted because people see it as a real environmental need. We want people to adopt this technology because it's cheaper and performs better than plastics, right? Because that's easy. That already fits into our cultural values. And then our sort of sneaky little run around the end is that it's actually better for the planet.
Eben and I were in the same classes for basically all 4 years at college. And we knew very early on, we started collaborating on projects, that we were a really good team. And we knew that we wanted to do something different. And we really wanted to do something that had an impact on the world. And when Eben first brought this insight to the table about using fungal mycelium, or this biology, as a grown glue, that was amazing. It was really changing the paradigm on how we use materials today.
It's really simple. We take an agricultural byproduct like a plant stock, we wet it, we cook it, and we grow this organism over the surface. And then we'll take a whole bunch of those and we'll squish them into a shape. And then that organism continues to grow and digest the plant husk and creates this complex network around it, binding it together. It essentially becomes a cohesive whole. And all you have to do when you're done with it is dry it out. So you get something that kind of looks like foam, performs like foam, but is biocompatible with our planet. It was like, wow, if we can do that, we can make a building installation. We can make a molded packaging part. You can make almost any kind of physical material. These materials practically grow themselves. They're fire retardant, they're self-healing, compostable, and our vision is to replace disposable plastics across industries and across applications.
This isn't an old science. This isn't something that people have been doing for centuries. This is something that we've been doing for 5 years, and the possibilities are really endless.